Hello. We will see in this tutorial how to use the function convert a network into a singular element. Here is a fluid network that has some complexity. We are going to transform it into a singular element. With that, this function convert to singular element. To convert to a singular element, a throughput test must be carried out in the middle of the usual range of use for this network. So we launch a flow test in the usual range of flow use. We can observe the result by doing a test of particles moving in the network. The network is in the calculated state. We know the pressure drops, and we know the pressures in the network. So we will be able to establish a global pressure drop curve for this network, and apply this pressure drop curve to the single element that will correspond to this network. So now we can use the convert network function. We will name this new network converted into a singular element. And so we can register it as a singular element. Using the singular element we just created, we go to the library. We find our singular element representing the network, and we drag and drop it into the new project. So here we have a new project with a singular element, which is therefore the representation of a more complex network. We are going to redirect it because it is not oriented properly. So we insert an orientator, and we're going to put the network in a good position. So we're going to do a speed test to see how it behaves. So we will notice a small nuance compared to a real network. A lattice simplification into singular elements will have a particle path, which will simplify the trajectory when there is a bifurcation. Here we come to a fork. The fluid will go directly to the connection of the bifurcation to resume its path through the network. So that's the only small difference that we can observe on a purely visual element. Of course, the system pressure drops are identical to a real network. This simplification of the network into singular elements makes it possible to build complex systems without having the heaviness of integrating each element of subnetworks. Here, we are doing a comparison test of pressure drop curves. We are going to enter the pressure drop curve comparator, the real network as initially modeled, and its conversion into a singular element. We see that the curves are indeed identical. So here, in this project, we only have one element. It's the element simplifying the network. We can, from these elements, continue after putting pipes and work as behind any singular element. So we see here, we will add a small piece of pipe behind the network. And we can therefore continue. behind this singular element representing a network. We run a small throughput test to see how the connection between the network element and the network suite is done. So we will use this function to convert a network into a singular element to make networks already designed usable as modules in other networks. There, you see, we have integrated again this singular element representing the network to create an even more complex network. But in reality, thanks to this simplification system, we will only have a few elements simplifying the global network. That's it for this tutorial.